All right, we're going to work with graphing the cotangent function. So here's the equation for the cotangent function. The period between the asymptotes is pi. The domain is all real numbers except for the multiples of pi, so those are where your asymptotes will occur. The range is all real numbers. You're going to have vertical asymptotes at multiples of pi. The x-intercepts are the midway points between those asymptotes, and the function has origin symmetry. So I want to review the unit circle and some angles. So here's 0, pi over 2, and pi. And then we have some ordered pairs, 1, 0, 0, 1, -1, 0. Now, the cotangent is taking the cosine value, the x, divided by the sine value, the y. So let's look at the cotangent of 0 radians. So here's my x and there's my y. If I were to divide x divided by y, so 1 over 0, it makes it undefined. So looking at the graph in the yellow box, at 0 radians, we have an asymptote there at 0 radians. Now I'm going to go ahead and take the cotangent of pi over 2. Take your x divided by your y. So here's your x, there's your y. So 0 over 1 is 0. So looking at the graph, here's pi over 2, we are up 0. Now let's do the cotangent of pi, x divided by y. So here's your x, there's your y. -1 divided by 0 is undefined. So you have another asymptote at pi. Now we have more ordered pairs that exist between 0 and pi. So if I were to take pi over 4 and I take the x divided by the y, so square root of 2 over 2 divided by the square root of 2 over 2, I get 1. So where is that on my graph? Right here is pi over 4, I'm up at 1. At 3 pi over 4, when I take negative pi over 2 divided by pi over 2, I get -1. So here would be 3 pi over 4 and then down 1. So this is our first snake, very similar in look to our tangent function. But notice it's rising on the left and it's falling on the right. And then the asymptotes are in a different place. They are at 0 radians and pi radians, where in the parent function for the tangent, it's at -pi over 2 and pi over 2. There are going to be some variations to your cotangent function, so those are going to be your children. I have broken them down into the steps that you've seen in a previous video, so we will go ahead and tackle those. The big thing you'll notice the difference is we are going to be setting the left and right endpoints equal to 0 and pi because these are the parent function asymptotes. All right, so let's go ahead and do this example of a transformation. So in this problem, there are going to be two transformations. The first number of 3. This tells me it's going to stretch vertically by 3. So it's going to be a taller set of snakes. There is not a horizontal reflection because we do not have a negative a. Then we tackle the period. The period is your b part. So pi over b, which is 2. So between the asymptotes, you're going to have a distance of pi over 2. There is not a vertical stretch. There is not a d, or vertical shift, excuse me. So there's no d. All right. So to find the asymptotes, we're going to work with that 2x equaling 0. So our left endpoint, we're going to set 2x equal to 0. And then that right endpoint, that right asymptote, equal to pi. And then we'll solve them for x. So in the first equation, we're going to divide both sides by 2 and simplify it. So our left asymptote will be at 0 radians. Divide both sides by 2. Our right asymptote will be at pi over 2. All right, so I'm just going to stretch out this horizontal axis a bit. So I'm going to say this is, well, I'll go a little bigger so you can really see the difference. I'll say that's pi over 2, and this is 0. And then I have my 4 increments in the middle. I use my midpoint formula. Pi over 4, halfway again, pi over 8. So each increment is pi over 8. So pi over 8, 2 pi over 8, this would be 3 pi over 8, and then 4 pi over 8, which is pi over 2. So what you have is this period of pi over 2, and then we're going to have to vertically stretch it by 3. So here is our period of pi over 2, and then we're going to vertically stretch it by 3. All right, so we're going to create the asymptotes. At pi over 2 and 0. Now we're ready to start graphing it. So you start in the center, and now if you remember, a cotangent function is going to rise on the left and fall on the right. So the next increment of pi over 8, we're stretching it up to 3. And then at 3 pi over 8, we're stretching it down to negative 3. And now we're going to create our snake. So this would be 1 revolution. If you wanted to make another revolution, you would create another asymptote at negative pi over 2, split it into 4 equal increments, create your next asymptote, label that asymptote, And now create your snakes. So center is at negative pi over 4. At negative 3 pi over 2, we're stretching it up to 3. And then at negative pi over 8, we're stretching it down to 3 in the negative. And there is another revolution, another period of pi over 2.